Hey everybody, welcome back. Today we're going to work again on lesson 3.6. I have split this lesson up over 3 days because it is just quite complicated. So today we're going to move our focus from the translations where we move something up or down or right or left. Now we're going to focus more on reflections where you take a line and you flip it right over the x-axis or you flip it over the y-axis, whichever way you need to flip it. So I wrote the definition straight out of the textbook here from this description. It says a reflection is a transformation that flips a graph over a line, which is called the line of reflection. So it's not going to be good enough today just to say, oh, it's a flip or it's a reflection. We're going to have to say, what did they flip it over, right? Did they flip it? Is it a reflection across the x-axis or is it a reflection across the y-axis? So really quickly, how these will look in the format that you'll see in your book. The regular equations will look like this, just y of x or f of x equals x. But what you'll start to notice is, if you remember the ones we did last week, I'm sorry to interrupt here, the ones we did last week, they would take the normal equation and they would either put a plus part at the end, right? Remember, that's going to move it up 5. This would have moved it down 5. This one, if it was in the parentheses, right? Remember, it's the opposite of the way that it looks. This is going to be 5 to the left. And this is going to be 5 to the right when it's inside the parentheses, right? That's up 5, down 5, 5 to the left, 5 to the right. So we were messing with the letter x and adding and subtracting really, really close to the x or even in the parentheses with the x. On these, you're changing just a negative sign, right? When they want you to flip it over the x-axis, they will put a negative sign in front of the letter F, or this doesn't have to be an F, right? It could be a G, an H, a K, W, whatever letter they have here. If they put a negative sign in front of the parentheses, in front of the function letter, whether it's an F or a G or a J, whatever, if the parentheses is out in front of that, this is always going to be a reflection over the x-axis. So I'm just going to make a line, for example, this is not a certified graph or anything, I'm just kind of freehanding. So if I flip something over the x-axis, remember this is your x-axis right here, here's your y-axis, this would take the line and flip it from here to flip it down here, right? So instead of this dot being 3 above, now it's going to be 3 below the origin. Instead of this dot, well, this dot will actually stay on the origin, right? This dot way up here that looks like it's 1, 2, 3, 4 places above, now it's going to be 4 places below. 1, 2, 3, 4, way down here. And so a reflection over the x-axis is going to look kind of like that, where you take a line here and you flip it down like that. The other option is a reflection over the y-axis. Notice the difference. Look where the negative sign is on this one. Now the negative sign is inside the parentheses with the input, with the x. When the negative sign is inside the parentheses with the letter x, you're changing the input number, and in that case, you're going to take your line and you're going to flip it over the y-axis. So like instead of having this dot right here, instead of, earlier we said it was 4 up above, and so we made the dot 4 down below. Now we're thinking about right and left, right? This dot is 1 spot, actually looks like it's 2 spots to the right of the y-axis. So now I'm going to go, instead of 2 to the right, I'm going to go 2 to the left. This dot that's on the x-axis will stay there. This dot down here that's 1, 2, 3 to the left is now going to be 1, 2, 3 to the right. And you see the difference, right? This is a reflection over the y-axis, and this one down here is a reflection over the x-axis. It kind of looks like they're parallel. That usually doesn't, I don't think that usually happens, but just kind of how it looks on this one. So just real big ideas here. Whenever the negative sign is right here, that's what you're going to be looking for. These letters are going to change. They won't always be F's. They'll be J's and G's and K's and W's and B. It doesn't really matter what letter it is. Don't let that throw you off. If the negative sign is out in front, whatever the letter is, this is a reflection over the x-axis. This is going to change your outputs. I'll explain what this means in just 1 second. If the negative sign is in the parentheses, big difference. See how this is in the parentheses with the letter x. Now this will always be, well, it's not always, but most of the time this will be an x. If it's in the parentheses with whatever letter is in there, now you're changing your input, and I'll explain what that means in a minute, and that means it's going to be a reflection over the y-axis. Over the y-axis. Up here is over the x-axis. Okay, those are the big ideas I wanted you to get out of those little examples. Boom, boom. Okay, now let's see what it looks like in action. So this could be a real question, right? You might have to do this on the computer or graph it on your own. Using the letter F, graph G and H. Describe the transformations from the graph of F to the graphs of G and H. Okay, so they're giving us like a quote-unquote normal one. That's the letter F right here. This is our normal one. This is our baseline. This is just our regular one. And then they're giving us all this shenanigans. Look at this. There's no numbers even in here at all, is there? It's like its own different language. So this one just means for the letter G, we're going to do the negative f of x. Negative f of x. Look where the negative sign is. We just talked about that on the last one. That's going to be a reflection over the x-axis. We're going to change the outputs. And then for the letter H, look, now the negative sign is inside the parentheses with the input, with the number that we're plugging into the problem. That's going to move it over the y-axis. All right, let's just go ahead and do it. Hopefully that'll get me close to about 15 minutes or less on my video. First thing, I really hope you're doing okay on graphing these. Could we just graph this in about 10 seconds? I mean, I hope so. Right? Can we find the y-intercept number? Like, which number is the y-intercept? It's obviously the 1. Can I just put a dot? Here's my y-axis, right? Here's my x-axis. You don't have to label it, but I'm just going to for your own benefit. Could I just put a dot at 1 on the y-axis? And then this is the slope. The slope is 3, or 3 over 1. The slope is 3. That means from this dot, not the origin, but from this dot, I'm going to go up 3 over 1. Up 3 over 1. And it should make a nice straight line. I'm not the greatest artist, and you can tell all my spaces there aren't spaced together perfectly. But this is our normal one, right? Now, if you didn't understand a single word of what I just said there when I graphed that, oh boy, what could you have done instead? You could have done this. You could have made a little chart for yourself, right? We're going to compare x to the function of x, which is kind of like the output. And you can pick the easiest numbers you want, right? You can pick 0, you can pick 1, you can pick 2, and then you just plug them in. If you put 0 in there, 3 times 0 plus 1, right? 3 times 0, that's a times, plus 1. You can put the number 1 in there, 3 times 1 plus 1. You can put the number 2 in there for the input, right? 3 times 2 plus 1. And if you work all of these out, this is 0 plus 1. This one equals 1. This one equals 3 plus 1 equals 4. And 3 times 2 is 6. 6 plus 1 equals 7. You get the points 0, 0, 1, which is right here. The second point is 1, comma 4. 1, 1, 2, 3, 4, right here. And then the third point is 2, comma 7. 2 to the right, 7 up. That's this dot right here. So if you are not good at just graphing them kind of freehand, even though it's not freehand, graphing it just using the slope and the intercept, you can do one of those tables. That's completely fine. Okay, now for these ones that get twisted, look at what this one is saying. I'm going to do this orange one. For the letter g of x, let me move my little table down here. Okay. For the letter g of x, look at the instructions it's telling us. It's telling us to do the negative function of x. The negative function of x. What that means is pick the numbers that you want. Let's just pick easy numbers again. Let's pick 0, let's pick 1, and let's pick 2. You're still going to plug it in just like normal. But what we're going to do is when we get our final answer, we're going to take our final answer and we're going to flip it to the opposite sign. That's what the negative sign is telling you. So when I put 0 in here, just like I did on the last one, 3 times 0 plus 1. On the second one, I'll put 1 in here. 3 times 1 plus 1. If I put 2 up in here for the x, 3 times 2 plus 1, right? If I work these out, I'm going to get the same exact line that I did a second ago, right? 0 plus 1 is 1. 3 plus 1 is 4. 6 plus 1 is 7. That would be the normal answer. That would be what we did on the black line. But because this has this negative out in front of the letter F or the letter G or whatever, what that means is we're going to take our answer, every single one of these answers, and we're going to multiply them by -1. Or to be honest, what that means is you're going to change the sign of all of these. So anytime you get a positive, flip it to a negative. Anytime you get a negative, flip it to a positive. And now I'm going to graph the point 0, -1. Look where that is. That's down here. Completely different spot than the last one. I'm going to graph the point 1, -4. Way down here, 1 to the right and 4 down. I'm going to graph this point 2, -7. 2 and then -7 all the way down here. Whoops, that is not 7, that is 8. 1, 2, 3, 4, and that wasn't 4. Oh boy. 1, 2, 3, 4. I need to learn to count. 5, 6, 7, right here. And so you've got your 2 lines. There they are. This is our g of x. All right. What did we just do right there? We took this line and we flipped it over the x-axis where it says describe the transformations from the graph of f to the graph of g. So this is a reflection over the x-axis. Or you could say on the x-axis or about the x-axis, but I like to use the word over. Okay. So what did we do there? We picked 3 easy numbers, plugged it into the original problem, and then whatever answer we got, we just flipped it to the opposite sign. You change your output, right? We change these numbers right here, 1, 4, and 7, to the opposite. We change the output whenever you want to flip it over the x-axis. Okay, I'm going to erase that. This purple guy is going to be the complete opposite. Now we're going to flip things over the y-axis. Let me fix this after I kind of messed it up. How's my time? 11 minutes. Okay, I'm hanging in there. So now when I do this last one, if I do x and I do, I don't know, h, whoa. When I do this last one, the purple guy here, if I pick x and then I do the h of x, okay? When I do this last one, I'm going to pick my numbers. You know what? Instead of picking 0 on this one, I could pick 0 again, but just for the sake of explanation here, I'm going to pick a different number. Let's say we just pick 1, 2, and 3. Now we're going to change. Look what this has. This says h of x equals the function with a negative x. This is inside the parentheses. So I'm changing the input. So I'm not changing my final answer. Remember on the last one, we changed the stuff over here. We changed our final answer. I'm changing this number to its opposite. So instead of putting 1, I need to put -1 in here. So I'm going to change this to a -1. That's just an arrow. I'm going to change this to a -2. I'm going to change this to a -3. If you had picked 0, I know I picked 0 on the others. Can I change 0 to -0? Technically, no, right? So if you pick 0, that actually gets to stay as a 0 because there is no such thing as a -0. But you see how the difference is on this one compared to the last one? On the last one, we worked it out normally and then just changed our final answer, our output over here. We changed this to the opposite sign. On this one, when the negative is inside the parentheses, you change your input number to the opposite sign, and then you work it out like normal. So for this one, I need to put -1 way up here into the original problem. So I need to do 3 times -1 plus 1. And if this next one, I don't want to put 2 in there. I want to put -2. 3 times -2 plus 1. Right? When I take my number 3 and stick it right up in here for the letter x, it's not going to be 3. It's going to be -3. It's going to be 3 times -3 plus 1. And if you want to put 0 in there, I'll just show you how it works. If you put 0 in there, you would do 3 times 0, because there's no such thing as -0, plus 1. And so they are going to have one of these. This is going to be a little bit of a overlap, like they're going to have a couple points in common. So let's just solve these. 3 times -1, that's -3. -3 plus 1 is -2. Here, 3 times -2 is -6. -6 plus 1 is -5. 3 times -3 is -9. -9 plus 1 is -8. And then here, 3 times 0 is 0. 0 plus 1 is just 1. And so the points that I'm going to graph, I'm going to graph 1 with -2. I'm going to graph 2 with -5. I'm going to graph 3 with -8. I'm going to graph 0 with 1. I'm going to graph those 4 points. Let me put it in purple so it kind of matches what color I wrote this one in. 1, -2 is right here. Right? The point 2, -5. 2, 1, 2, 3, 4, 5 down here. The point 3, -8. 3, -8 way down here. And then the point 0, 1 is right here. So if you look at this line, it looks kind of similar to the other one, just with the way that they graphed it. Looks kind of like that, right? So that is kind of how those work. It is not the easiest thing ever, but you can see like our points here, like this dot right here, instead of being 1 to the right, and now I have a point kind of like 1 to the left. This dot up here, I didn't use any negatives, but you see how this is like 2 spaces to the right. Now if I go 2 spaces to the left, I'm right on the line, right? So that is kind of the process you'll use for these, okay? And if I wanted to describe the transformation from the graph of G to the graph of H, this was let me erase all this so it's not in the way. This one is a reflection over the y-axis. Reflection over the y-axis. So big idea there. I'm going to wrap this up. I'm at almost 16 minutes here. Big idea. Whenever they put the negative sign out in front of the parentheses with the letter F or G or J, whatever letter they use, when the negative sign is out there, you solve it like normally, pick the regular points you want for your input, plug it in, and that's whenever we change the final answer, right? We turned 1 to -1. We turned this answer, it wasn't on this one, but before I erased it, you change a 4 to the -4. Whenever they put the negative in the parentheses, you're changing the input. So I changed this number to a negative, and then I plugged it in way up here and worked it out. So it's just a difference of where you flip the numbers, right? If it's a reflection over the x-axis, you just change the answer on your output. If the negative is in here and it's a reflection over the y-axis, you change your input number before you substitute it in. It just matters when you change the sign, right? Reflection over the x-axis, when it looks like this, you don't change anything until you get your final answer. You don't change it till it's over here. You change it at the end of the question. Whenever it looks like this and the negative is in the parentheses, you change your number right at the beginning before you plug it into the problem. You change it to the opposite sign. Okay, guys, that's it. I'm going to put a few questions on Big Ideas Math. There's not going to be too many, so don't panic. I know this video is kind of long. Do your best and ask me if you have any questions, and I'll catch you in the next one. See ya.